Thank you. Thank you. All right. I'm so curious what my slides look like on this big ass monitor. Holy. I thought about just doing 20 minutes of hacking and showing it on there, but I think that looks Yeah. All right. So what's up, everybody? My name is Wes Bos. I am Canadian, as we just said, and I do a couple things. I make web dev courses, and I have a podcast and YouTube channel called Syntax. Anyone ever heard of Syntax here? Woo! Yeah. So today I'm here to tell you about how awesome the web is. It feels like HTML, CSS, JavaScript feels like the last couple years, and maybe you haven't even heard of it, but like there's a lot of stuff that has landed. It's quickly improving. Things are moving extremely fast right now. So today we're going to look at some of the new features that you can either start to use or look forward to using in 2025. So the first one we have here is customizable select. So the great thing about built-in inputs to the browser is they're built in, and that's about it. The rest of them, they suck. Nobody uses the built-in inputs or the built-in UI things in the browser because you can't style them. You can't get them to do what you want, and that is starting to change. And one of the very first ones we have is this customizable select, which will allow you to put any HTML, CSS, and JavaScript inside of a select, and you can build any select box that you want, and it's all backwards compatible, and it's still a select element at the end of the day. Next one we have is Temporal. Temporal is standardized API for working with dates, time, and duration. So here's a couple problems we have with the current data API in JavaScript. So you make let's say you want to tell your employees, hey, you have January 22nd off, right? You create a new date, January 22nd. You tell the New York office, hey, remember you have January 22nd off, and then you go to those losers on the West Coast and you tell them that they have the 20. Just joking. You go to the San Francisco office and you parse that out to a date, and all of a sudden they have the 21st off because you forgot about time zones, right? Who here's been bit by a time zone bug before, right? That's really annoying. So with Temporal, there's a whole time zone API. It's actually really flexible, but you can create dates in Temporal without a time zone attached. You simply just say January 22nd, 2025, and that's not specifically attached to any time zone. Another one is you can specify dates without a year, right? Or you can go ahead and add a year. So if you want to say I was born on December 15th and you want to figure out what your birthday is in 2023, it will tell you what day that actually is. Or if you want to create durations, right now if we want to create durations that are not attached to a date, we just use milliseconds, right? So temporal durations will allow us to do things like 1 minute and 30 seconds. There's a nice API for adding them. And then there's also a really nice API for finding the difference between two dates, right? So you can take your birthday, and you can say, what is the time since that birthday? Really cool API. Next one we have here is called Invokers. This is sort of like declarative click handlers, meaning that we have these really cool APIs in the browser like popover and dialog, and if you want to open and close them, there are some commands for doing that. But then if you look at something like a video player, if you want to have a button hooked up to a command on your video player, you have to select the item, attach an event listener, or check if the item is there, then attach an event listener, and it's a whole thing, right? This API will allow us to say this is a command for this element, and this is the command that I want to run when you actually click the element. There's no JavaScript involved. I'm sorry, this is a JavaScript conference, but no JavaScript involved in that one. Next one we're talking about is called speculation. This is for pre-rendering and preloading your pages. So I had this video go pretty popular in the last couple of weeks on why the McMaster car website was so fast. And a huge reason behind why the McMaster car website is so fast is that they're simply just preloading a lot of the HTML on the pages. It's something that's been possible for quite a while. So the speculation API is now going to allow you to do something like this. Script type equals speculation rules. And inside of that, you can basically give it a bunch of regexes for stuff you want to find on the page that should match. You can use CSS selectors as well. And that's really cool because you can tell it, hey, if you find links on the page that match these things, maybe go ahead and either pre-render or pre-fetch them. So Harry Roberts, CSS Wizardry, already has this on his website. You can take a look, and you can specify different eagerness. You can specify if it is going to be pre-fetched, which means it just goes and downloads the HTML for that page. Or you can specify if it will be pre-rendered, meaning it will download all the HTML, CSS images and actually render it in a separate tab. And then when you click the link, boom, it instantly moves over. There's some really cool dev tools that will show you the browser is in control of whether it will do it or not. So things like data and battery and where the link is on the page, the browser will make the decision of if it should do that or not. So you're not just downloading 14 gigs of HTML on every single page. The CSS Anchor API, this is really cool. So the CSS Anchor API is going to allow you to position elements based on another element's location, and they don't have to be in like the same parent, or they don't have to be positioned relative or anything like that. So you simply just say price, anchor name, you give it a variable. So now you've named the price. That's the $5.99 in the video here. And then you have a call to action that says great deal, and I'm saying position anchor yourself based on the price. Then you can put them in the top center, and then when it goes off screen, it no longer fits there, right? We've had this with tooltips a lot. It's like, where does the tooltip show up? Well, wherever there is space. So you can tell it, well, when you no longer have space on the top, flip block. Just flip to the bottom, and it just automatically does that for you. You can also specify custom positionings here. So you can name custom positions with this @position_try API. And then when you go ahead and use it, the last line here, position try fallbacks, you can say, try what I told you at first. If that doesn't work, you can't fit it on, then try custom. And then if that doesn't work, then flip it block. And you can basically just give it a whole list of positions to try. This is going to be huge for tooltips and huge for context menus. Web components. So I'm here to tell you today is that you don't have to love writing web components, but you'll probably actually enjoy using web components. So web components are encapsulated. They can take HTML, CSS, and lots of JavaScript logic and encapsulate them all together. They're framework agnostic. They work on whatever framework you want. They're easy-ish to style. You know, it's a little bit of a different approach for some use cases. They're a breeze to use, and they're standardized, meaning a web component you write today is going to be available in 10 years from now, unlike many of the frameworks that we have. I can hardly take a weekend off without things breaking. Now, this example here is something called Media Chrome, which one of the hardest pieces of media UI to build is a video player, right? And a video player has lots of stuff. You got skip buttons, you got thumbnails when you hover over top of the scrubber bar. You've got different like 1080p, 1440p, full screen, Apple Play, Chromecast, all of these different things. And like I just wrote some what seems like HTML here, and I have a fully featured video element. And there's some poor soul that wrote this web component for me that took a lot of hard work, and I just get to go ahead and use it. And this is really exciting when you start to look into like UI components. So there's this project called Shoelace, which is making lots of really cool web components, things that we need, because it probably doesn't make sense that we all rebuild the same web components, or sorry, it doesn't make sense that we all build the same UI components over and again, because you got to think about mobile, you make sure they're accessible, you got to make sure that they look good. So Shoelace, it's actually called WebAwesome now, and they're going to release a whole bunch of web component standardized components. AI. Let's talk about AI, right? I'm sure everyone's kind of sick of this, but this is kind of cool stuff. There's this library called Transformers.js, and this allows you to use the models that are used in AI, but run them and interact with them in JavaScript land, both on the server and on the client. So a couple examples that we have here is emotion detection. So what I did is I took something like I don't know, 500 thumbnails from an image, and I put them all through an emotion detection model, and then it told me which ones are the most happy. And we need this for the thumbnails for our podcast. Is I need to find where I look the most smiley, so we can put that one on the thumbnail on YouTube. We also have client-side depth detection. This one is really cool. So what this does is, again, I'm doing this all in the browser. I just took a photo of myself, and based on what it knows about depth detection, this is actually how Tesla does its like self-driving. It will give you a map. You can kind of see it in the top left-hand corner. It's called a depth map, and then you can feed that to something like 3JS and actually have a full 3D experience, and it works really well, right? Oh, my daughter's calling me. Not now. Background removal. So, like, you might think, like, yeah, this stuff is meant to be done in Python, but, like, you know where Python doesn't run? In the browser. JavaScript runs there. So, if you need to do something in the browser, you get, like, background removal, do it in the browser. You don't have to send it to a server, process it, pay for that, and then send it back. You can simply just do it right away in the browser if it makes sense for the app that you're building. Now, these models, like why would we want to even do this? Because these like small models are, well, they're not all small, but they're relatively small versus the overhead of maybe sending it off to a server. So this modnet, which was used for detecting my smiles, 6.5 megs, right? Like that's pretty big to load on the client, but depending on the application, maybe it's not so big. And then also it's faster. So the reason why this is like that's really fast to remove a background. This is happening in real time. I'm just doing one and then the next one, right? So the reason why that is so fast is this new API called Web GPU, which will allow you to access your user's GPU in the browser. Window.ai. So this one's maybe not coming. This is more of an experiment from Chrome, but I thought I'd talk to you about it. There is a push to allow you to just access the models from the browser. So imagine you're building an app and you say, I want to use AI. Well, imagine you could just call Window.ai and you can use the model that's on the user's device already. In this case, it's Chrome has this. Next one, Calc size. This one is like probably the one problem that we've all wanted to do, and that is simply animating height auto like we did in jQuery 27 years ago. So very simple example, height 100 pixels, transition, height over 0.2 seconds. And then when you hover, I want to set the height to auto because I don't know how big this thing is going to be. And in this case, we simply just say calc size auto, and then you'll be able to transition them from one to another. Starting style, this one's really cool. So how many of you have ever done like animation in React or Vue or something like that, right? Where you want to animate something in or you want to animate something out. Those things can be a little bit tricky because you often have to add a class and then like 10 milliseconds later you'll add a second class, and that way you can transition from A to B. Right? With starting style, what you can now do is say when an element is added to the DOM, apply these styles at the start, and then immediately apply the regular CSS styles that you're used to. And what that allows us to do, in this case, I'm simply just saying, when you start, translate x negative 100%. So just move it off the page by default. And then when you apply the styles, translate x 0. And then they just whoop, zoom right on in as you need them. View transition. So this is a really cool one where it's both a CSS and a JavaScript API. So here's a little demo I did where this is 16 video elements on a grid. And what I'm doing is I'm offsetting the position of the video element in each of them. So 16 different videos. And when I click on that randomize button, I'm taking all 16 of those elements out of the DOM, shuffling them, and then putting them back into the DOM in a random order, right? I'm simply just updating the order of 16 elements in the DOM. So what that looks like is each of those divs has a view transition name on it that is unique to that element. And then I use a little bit of CSS to say, when you transition yourself, add this animation timing function to it, right? You could rotate them, you can zoom them, you can fade them in and out, whatever it is that you want. Then I simply just need to, before I do, I shuffle the items, and before I actually update the DOM, I tip the browser off to say, hey, start view transition. And what that will do is it will say, OK, well, it sounds like you're going to change the DOM in some way. And after you've changed the DOM in some way, I'm going to figure out where that was and where it's going to be. And I'm simply just going to morph them from one to another. So again, if we come back to my demo that I have right here, again, I'm just taking the elements out of the DOM, mixing them up, and putting them back in. But because I'm using view transitions, the browser is able to figure out it was there, now it's there. I can then animate it from one place to another. There's no duplicating elements. There's no that flip technique or anything like that. It just works really well. And that's the JavaScript API, but it works with just CSS as well. This is the syntax website, where on the card view, that's an H4 with a view transition name. And then when you click on one of the pages, there's an H1 with a view transition name. Doesn't even have to be the same element. It's two totally separate pages. And when you go from one page to another, the browser says, oh, there's something with the same name, and it was here, it's going there, I'll figure out how to morph it from one to another. CSS relative colors. This is really cool. So if you have come from SAS world, probably one of the things you're missing in CSS is the ability to just simply make something lighter or darker a little bit, right? And now you can do that in CSS. So the way that it works is you take HSL or RGB or any of the color functions that you're used to using, and you use the from keyword. And you say from, in this case, I'm taking a hex, and then it gives you three variables, the H, the S, and the L. It will also give you an alpha value if you have it. And you can take those variables, HSL, and do whatever you want with them, right? In this case, I'm simply just taking the lightness and cranking it up 40% or bringing it down 20%. So this little demo I did here is, I've always had this question of, can you programmatically make good design? The answer to that is no, but there are some things for finding complementary colors, and there are algorithms to turn the degrees of colors in their color space to find things that look decent. So here I have one hex code, and literally every other variable in this is calculated based off of that one hex code. It's something like 40 or 50 different HSL from functions. Scope CSS. So Scope CSS is really cool. It's here. It's in all the browsers. And then the way that it works is, well, there's kind of three different ways to use Scope CSS. So the first one is implicit scope. So you can literally just put a style tag inside of a div and say @scope. And the CSS will then just be scoped to that div that is the parent of the style tag. It will not escape and cascade or like apply to other things that are on the page. And it's kind of cool. So you use @scope, and then you use :scope to access the scope container. And then you can select anything else inside of that div just with regular CSS selectors. Then there's also explicit scope. So if you want to put it in a separate CSS file, you could say @scope.card, right? And then that will allow you to access or write CSS that is only applied to something with a class of card. And then, of course, you can stick container queries and media queries. You can stick any of the other stuff that you're used to doing inside of that scope, and it doesn't leak on out. And then there's also this thing called donut scope, which is like a lot of people who here uses Tailwind, right? Like lots of you. And the reason why people, myself included, like Tailwind is that it doesn't cascade so much. And with donut scope, you can stop the cascade. So you can say, start the scope here, But like if there's something nested in, or you're trying to scope something really high level, if you have a card inside of a card, you can stop the scope from applying, and it's really cool. So basically, you're saying start the CSS here, and then no longer cascade any further than this. How much time we got here? Oh, we're doing great. All right, web primitives. This is really interesting. So we have all of these different JavaScript runtimes now, right? Like we have Node, Deno, Bun, Cloudflare Workers. I think there's 7 or 8 different server JavaScript runtimes. And then we also have like 3 major browser JavaScript runtimes. And it's just like, wow, like that's kind of a lot, right? So the answer to writing modern JavaScript code is using web primitives as much as you possibly can. And so one example of this is fetch, web requests, and web response. And you've probably written this code before where if you want to send a fetch request, you might just write the fetch request. But what's actually happening is you're creating a web request, and then the response to that web request when you pass it to fetch is a web response. And it actually works exactly the same way on the server. So if you write a handler for when something comes in, you get the request. You can access all the information about stuff that's been get or posted to it. You can access cookies and headers and things like that. And then what do you send back from a handler? A response, right? We're kind of lucky if you use JavaScript on the server as well, you're kind of lucky that you use the same primitives both on the client and on the server. And what that allows us to do is you can write the same handler and run it in Deno, Node, Bun, and Cloudflare Workers, and it'll actually run in Web Workers in the browser as well. And that's not the only one. That's just probably one that you've touched before. But there are a whole bunch of these new standards that you should like build your stuff on because they will work absolutely everywhere. And much of like Remix and things are built upon this. In fact, we're starting to see things like Hano and Nitro that are entire frameworks meant to replace like Express.js with these web standards. And so that's all I have today. That was a lot of me just kind of running through a bunch of the new stuff. I probably could do about 4 more hours on all the new stuff on the web platform, but it's a pretty exciting time right now. Lots of changing. Yeah, let's go hang out after. We'll do 4 more hours. But the web is pretty awesome. Pretty excited about it. And thanks so much for coming out.